Lesson 2.2, Polynomial Functions of Higher Degree. What we should learn. Use transformations to sketch graphs of polynomial functions, use a linear coefficient test to determine end behavior, and how to find the zeros of polynomial function as sketching aids. So, like the last lesson we talked about what a constant function is, right? Polynomial functions are like a collection of functions like this, right? Where the power always has to be a positive number or 0. So when you have no power, it's a constant, it's a horizontal line. When you have a power of 1, the highest power of 1, then it's a line, also known as a linear line. And then when you have a higher power of 2, it's a quadratic. That's what we did in the last lesson, right? It's called a parabola type of graph. Now we're going to go higher. So the thing about polynomial functions, there's this fancy term you're going to do more when you take calculus. It's called continuous. That just means the graph is all nice and connected. This is a continuous function. So polynomial shows like this. How polynomials look. When you see a graph like this when it's not connected, this is not a polynomial. Right? This is a piecewise function. Piecewise can be continuous if they're done correctly, but not always. Right? So polynomial functions are always nice and they always look something like this. They're always nice and connected. Same thing here, just a little more info, right? Polynomial functions are always smooth functions. So again, always kind of look like this. This is a function, but it's not a polynomial function. That's like a sharp turn there. That's going to become important when you take calculus. So these are nice polynomial functions. They have special properties in calculus. Okay, so one of the polynomial functions we haven't talked about yet, right? In depth is x cubed, a cubic function. So this is what a cubic function looks like. We've seen it before in our parent graphs, right? The domain is negative infinity, positive infinity. Our range is negative infinity, positive infinity. It's always increasing. There's no decreasing. And it's an odd function. You can see what it looks, right? How these map this way. Odd function. So, as I talked before, these are polynomial functions, but when you only have a power of 1, like we have here, x cubed or x squared, we call those power functions. So, power functions are when it's like that. Those are a little easier graphs. So, when you have a graph like this or like this, those are called power functions. And we know those are part of the parent functions. Those are easy ones to graph. And let's do some here. Right? So, they want you to sketch the graphs of negative x cubed. So, I'm going to do that right here. Here's A. We want negative x cubed. So, just to show you, I'm always going to draw the basic one. You don't have to do this. I'd like to do this so you can see what I'm doing. So x cubed. And this first one here, notice how negative's on the outside. Outside y, so it's a vertical flip. So we're going to flip it up and down. So we're going to flip it like this way. We're going to flip it up and down. So this part's going to come up, and this part's going to go down. There's negative x cubed. So it's into that effect. Again, notice this is a sketch. I'm not going too crazy with it. B wants x cubed plus 1. So again, to show you, this is what x cubed looks like. So x cubed plus 1, right? It's on the outside, so we're going to move up 1. You can kind of think about it like if it's a vertex. It's not called a vertex, it's called your origin point, but we'll just say like your vertex is 0, 1. So we're going to start off at 1, and then we're going to do the exact same graph. Kind of like that. C, we're going x minus 1 cubed. So you probably know the answer to this. I'm going to do it really fast. There's my x cubed. Notice it's inside opposite, right? Inside, if x to the x is opposite, so we're going to move it right 1. So you can count the origin point as 1, 0. So right here, and then we're going to do the exact same graph, right? We move it all over 1. So it's into that effect. Let's talk about the leading coefficient test. This is one of my favorite tests because it's so easy and quick. So leading coefficient test, this lets you know the end behavior of the graph. So you can look here. Leading coefficient tells you like, oh, does it end on top or does it end on the bottom? Does the left end go up or down? That's what leading coefficient test tells you. And it's actually fairly easy. So first thing, if it's a positive x to the end, right, the leading coefficient, the number front, then on the right hand side, it's going to go up on top. So start right there. Boom. I don't know how that ends yet. We'll talk about that in a second. But if it's a positive x to the n power, it's going to start up on top. So you see here, leading coefficient is greater than 0. Positive starts on top. Even with this one with an even function, even power function, I should say, positive starts on top. So positive starts on top. If it's a negative ax to the n, then it's start on the bottom, on the right hand side. So you just gotta keep in mind you start on the right hand side, not the left hand side. And if it's positive, if it's like a positive 2x squared, starts on top, negative starts on the bottom. Right? You can look at our graphs we did earlier. Right? -1 start on the bottom. +1 start on top. +1 start on top. Okay, so that's the first part of the linear coefficient test. Just the number. Is that number from positive start on top, negative start on the bottom? Then we get to a little more complicated. Is it an even power or an odd power? Odd power, I like to say it switches. So what does that mean? If you start on top, and at the end you're going to start on the bottom. You're going to end on the bottom. Or if you start on the bottom, you're going to end on top. So if it's an odd power, it switches. Again, look at what we did earlier. X cubed, right? Switches. So if it's an odd power, odd degree, probably should say more correctly, it switches. If it's an even degree, power, stays the same. Think about like x squared, right? It looks like that. So if it starts on top, it's going to do all this stuff and it'll end on top. Or if it starts on the bottom, it's going to do all this stuff and to end on the bottom. So that's the linear coefficient test. First, you look at first you see if it's positive or negative. If it's positive, it starts on top, right hand side. Negative starts on bottom, right hand side. And then you look at the power, like the degree. If it's odd, it's going to switch. So it will go from top to bottom to top. If it's even, it's going to be the same. That's what they show you here. If it's odd, notice you start on top because it's positive. Boom, bottom. If it starts on the bottom, it goes to the top. And then if it's even, it's always the same. So that's the linear coefficient test. Let's do some examples. So like this one right here. Describe the right hand and left hand behavior. I'm just going to draw a picture. So first notice it's negative. So I know it's going to be on the bottom. And then it's an odd power. So we're going to switch. So it's going to do all that stuff, and then it's going to flip down there. So it's an inside effect. Right? Just shows me what it looks like. And like kind of. I don't know what the middle is going to be, but I know what the end behavior is, right? On the right hand side, it's going to go to the bottom. On the left hand side, it's going to go to the top. That's the key part there. So we're going to do again, just make sure we know what we're talking about. So in this case, this is positive. So for A, we're going to start on the top right. Then look at the highest power. That's even. So we're going to say the same. So we're going to end on top left. So you do like that. If you want, you could kind of like dot. Right. I don't know what the middle is going to be. Let's enter that effect. Now keep in mind, I don't care about these at all. Right? It's called the linear coefficient test. All we care about is the linear coefficient. That's it. B, positive again. So we're going to start on top right. In this case, we have an odd function. So we're going to switch. So bottom left. And then again, who knows how this middle is. Right? Middle could be anything. We don't know yet. We'll learn more about that in the future lesson. So that's the linear coefficient test. Again, one of my favorite tests because I think it's pretty easy and straightforward. Okay. How do we find the zeros of a polynomial function? The zeros of a polynomial function are actually super important. So first, what does a zero mean? A zero literally just means it's when f of x equals 0. That's all that means. If I say a 0, that just means that's where f of x equals 0. Hence 0. This is also sometimes known as a what? Oh, sorry, an x-intercept. But not always. We'll talk about this. This is the real zeros. We'll get more into this next lesson, but there's real zeros and there's non-real zeros. The real zeros are also known as the x-intercept. In this lesson, we're going to focus about real zeros. In the next lesson, we'll move on to non-real zeros. But today, real zeros. So, all these are real zeros. They're all equivalent. So, real zero is an x-intercept like I talked about of a graph. It's also a zero of the graph. We said it, right? That again, this means where does the function equal 0? It's also known as a solution. So if I was trying to solve an equation that was like this, f of x equals like x cubed plus 2x minus 3. If you set this equal to 0, then you're trying to find a solution. But that's also the same thing as finding the 0 or finding the x-intercept. They're all equivalent. And then it's also a factor. X minus a is a factor. We'll do this one more later. So that's another one we're going to spend more time on in our lesson. But all these are equivalent. So 0 literally just means like a solution, an x-intercept. A real 0, I should say, is a solution, x-intercept. It's just when the thing equals 0. So first question, let's find all the zeros of this one. So first we'll just find zeros mean, right? That means set this guy equal to 0. Now how would I find the zeros? I would factor, they all have an x, so you could factor out an x. Pull out the x and you're left with this. And then I would split and solve each one separately. X equals 0, that one's easy. 0 equals x squared minus x minus 2. Right, so I set this guy equal to 0, that's this one here. Then I set this guy equal to 0. That one's done, have one answer. Here I got a factor. So -2, -1. Well, two things will probably get -2, but I have to get -1. -2 and 1. So I'm going to get 0 equals x minus 2, x plus 1. And then split and solve, you should get x equals 2 and -1. So 0, 2, and -1 are my x-intercepts, or my zeros. And then one thing you should notice here, I have 3 solutions. That's a power of 3. This is something we're going to talk about more later on also, but whatever the power is, that's the most solutions you can have. So I can't have 5. You should get at most 3. Now, we'll go more in detail on this, but 3 is the max solution you should have. Real solution you should have. Okay, how about repeated zeros? Something called multiplicity. Sometimes you have the same answer more than once. So when you have a multiplicity, it depends on the power. So sometimes you might get something that looks like this. X minus 2 to the 3rd, x minus 3 to the 4th. Right? All we care about here is the power. This is an odd power. This is an even power. And it depends if it's odd or even what it does to the graph. When it's an odd power, it crosses the graph. So here at 2, my graph would cross it. Like that. When it's an even power, it touches it. I like to say it bounces off of it. So here at 3, we're going to hit the graph, but we won't go through this bounce back off of it. That's how multiplicity works. So anytime you have the same answer but like multiple times, it's called multiplicity, and the power does something. If it's an even power, it bounces, hits the graph and bounces. Always think about x squared, right? How it looks like it kind of bounces off the thing. And then that's an even power, even multiplicity. And then an odd power crosses. I always think about that as like x cubed. If you think of x cubed, right, it looks like this. Notice it goes 3, right? Because that's an odd multiplicity. So it crosses. When it's x squared, it kind of bounces. So we're going to analyze this graph here. So here's this graph here. This is our function. And we want to find all the zeros. So first of all, my zeros, right, they're also known as the real zeros are known as the x-intercepts. So if you look at my x-intercepts here, I have x equals -1.86. I have right there -0.25. This is like on a TI-84 calculator. That's why you see it like this. And then I have one more x0 right there. 2.11. Now look at the graph. What can we tell about the multiplicity here of all these? Well, none of them bounce. Kind of sucks. So they're all going to be odd multiplicity. See how this one crosses? So this is an odd multiplicity. This one's also an odd multiplicity. And this one's also an odd multiplicity. So they all cross through. So the multiplicity is odd. If one of them would have kind of gone down and then like hit it and then bounced off, it would have been even. But no such luck. Okay. Find a polynomial function with the given zeros. So it wants to find an equation with the given zeros. So this one's not as bad. Well, some of it's bad, but some of it's, the general idea is not as bad. So we want to find a function. So here's the key. Let's go back up to here. Notice my solutions were 2 and -1. How did I get them? I got them from here, right? I got them from this equation. So that's our first step. We're going to go backwards. If I know these are my zeros, I'm going to rewrite them like this. X. Now, it's always the opposite. If you look here, 2 is my answer. Where did it come from? X minus 2. -1 was my answer. It came from x plus 1. So when we write stuff like this, it's always written like this. X minus A, X minus B, etc. So this is going to be x plus 1/2, x minus 3, and x minus 3 again. So I'll put x minus 3 just to show you. So I'll put it like that just to show you. They're both 3, right? So I get this. Let me write it a little nicer. X plus 1/2, x minus 3 squared. So that's my polynomial with these zeros. Now, if they would have said put in standard form, I would have to like multiply it all out and get like something that looks more. So they like looks more like this: ax to the n plus blah 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 blah. Right? If they wanted standard form, I have to do that. But they just said find polynomial function, so I'm good here. They want me to sketch the graph of this by hand. So key thing here is find the zeros. So we're gonna set equal to 0. I could notice they all have an x to the third. Let's factor out an x to the third. We're left with 3x minus 4. Almost forgot the 4 there. We're going to split it. X to the third equals 0. And then we're going to go 0 equals 3x minus 4. Nothing you can do here. You just solve it. Cube root both sides, I guess. X equals 0, but we're going to say a multiplicity of 3. That's going to become important. And then here, solve it. Just add 4 to both sides and divide by 3. I'm going to say 4/3 equals x. Right, so I added 4 and divided by 3. And this has a multiplicity of 1. So if we're going to graph this, alright, so first my x-intercept I have a 0 here. That's 0. 4/3, so let's say it's 1. We'll put a point right here, so that's 4/3. And then they're both odd, so we're going to cross on both of them. I'll put a little c on top so I know. Cross and cross. Right, so I'm not going to bounce. What do I do next? Do I start on top? Do I start on the bottom? Where does it end? Don't forget our leading coefficient test. It's a positive. So we're going to start on the top right. And then it is an even power, so we should finish on the top left if we do everything correctly. And all we're going to do here is it is a sketch. There's many solutions. So right, sketch, so sorry. We're just going to go through the point. Now again, we cross. So we cross, and we have to hit this, and we go through that. So we get something like that. There's many solutions. This is a sketch, but I know my graph starts up here. It crosses the first one because it had a multiplicity of an odd multiplicity. At some point, it's going to curve and get through this one. It crosses through there because again, an odd multiplicity, and then it goes up. So that's a sketch. This next one, I'm going to sketch this one by hand. So same idea. First, I want to find the zeros. I would factor out all the x's first. So x negative 2x squared plus 6 minus 9 over 2. Let's split and solve. 0 equals x. That's easy. We have 0 equals negative 2x squared. I forgot the x here. Plus 6x minus 9/2. That's less easy. I'm going to do something, little math tricks, right? I don't like fractions for sure. I don't like the fact that it's negative. So I'm going to multiply both sides. But I'm going to try to get rid of this fraction. That's a 2, so I have to multiply both sides by 2. I'm also going to get rid of the negative though, so I'm going to multiply both sides by negative 2. So this side I still have 0. On this side, I get 4x squared minus 12x minus 9, plus 9, plus 9. Right, so I factored, like I multiply both sides by negative 2 to get rid of the fraction and to get rid of the negative. So I have this. I have to factor this. Right, we're going to multiply first and last, so I get 36, negative 12. What are two things I multiply to get 36, but add to get negative 12? That is negative 6 and negative 6. We are factoring the number in front, so we have to divide by the number in front. And you want to reduce if you can, so negative 3/2. Again, some fancy factoring, so if it's been a while, you probably want to review it. So I should get this. Equals 0, and then we're going to split, so we're going to get 2x minus 3 equals 0, so I'm going to get x equals 3/2 with a multiplicity of 2, right, because there's 2 of them, I just solved one, multiplicity of 2. So let's look at what we have. I have x equals 0, that's a 0, that's a multiplicity of 1, and I have x equals 3/2, that's a multiplicity of 2. if I had to graph this, a sketch. So we have a x-intercept at 0, and then 1 at 3 halves. So that's 1, here's 2, you're halfway. Now in this case, this one crosses still because of odd multiplicity, and this one's going to bounce. Right, so that one's going to bounce because it's an even multiplicity. Now where do we start, top or bottom? It's a negative, so we're going to start on the bottom. If we do this correctly, it should switch. Right, odd power. So we should start down here, and then we should end up there. Right, if we do that correctly. So let's just go. Goes here. Now I go to the first one. Remember, it bounces. So I'm not going to go up here. It's going to bounce back. So it's like this. And then at some point I got to cross and go through this one. And then we get that. So that's what it looks like. And that's the lesson.